Hey guys, today your video is on basic logarithmic form. It is another very important lesson, but it's one that I think you'll find is pretty simple. A logarithmic expression is going to contain a log, log. So log base 5 of 25 equals 2 is an example of a logarithmic expression. An exponential expression is going to have an exponent, like 5 squared equals 25. To convert from a logarithmic expression to an exponential expression, you do what I call the circle. Is it a perfect circle? No. Does it go in a circular motion? Yes. So you always start with your log base, travel across the equals to get your exponent, travel back across the equals to get what it's equal to. So log base 2 of 16 equals 4 as an exponential expression is 2 to the fourth equals 16. So what is the exponential form of each equation? We're going to do the circle because we're going from logarithmic to exponential. 2 to the third equals 8. 16 to the 1/16 equals 4. And that should be 1/2. Let's change that because I was going to say that's not quite right. 16 to the 1/2 is equal to 4. What is the logarithmic form of each equation? I always rewrite this with the exponent first. It's just me. You don't have to, but you can. So now you're going to undo the circle. So you're going to have log in your answer. The base goes here. The exponent goes here. What it equals goes here. So 10 squared equals 100. These are real easy to check. 3 to the fourth equals 81 in logarithmic form. Log base 3 to the fourth power equals 81. 3 to the fourth equals 81. All right, we've looked at change of base rules. We're going to look at it one more time. Log of B over log of A. Take a look at the example on the back. Find the value of log base 8 of 32. Remember, the change of base helps you convert to a log base 10 common logarithm. 4 decimal places. Log 32, enter, divided by log 8, enter, 1.6667. A common logarithm is a logarithm with base 10. And I think you already have this on your paper, but if not, fill it in. If there is no base in a log expression, I'm going to show you what that looks like. The base is an understood 10. Like log 27. So a common logarithm can be written in two ways: log base 10 of x or just log of x. A lot of times that 10 is not there. And a logarithmic function is an inverse of an exponential function. That's why we've been able to do all the work we've done in interchanging the logs and the exponentials. All right, if you will please pause your video, take just a minute, and I think, if I'm not mistaken, your instructions are already there. If you will just pause and write down 1 through 12. All right, write in logarithmic form, excuse me, means log will be in your answer. The base is the base of the log, what it's equal to, and your exponent. So 4 to the negative 3 equals 1 over 64. Feel free to pause your video and try these and then come back and check. Log 8, 1 over 8 equals your exponent, negative 1. Log 11 of 1 equals your exponent, 0. And log 17 equals your exponent, 1. Do your circle for number 5. 2 to the third equals 8. actually 10 to the negative 2 equals 0.01. Remember, if there's nothing there, it's an understood 10. And all these are true statements. 2 to the 7th equals 128. And 5 to the negative 4 equals 1 over 625. Now, evaluate. We haven't done any of these yet. The easiest way to do these is to go ahead and set each one equal to x. Do the circle. And then figure out what power of your base is equal to the number on the other side. If that's hard for you to look at and figure out, use the change of base. So going back to the original, log 64 over log 2 will get you the answer quickly, which is 6. 2 to the 6th power equals 64. So log 2 divided by log 8. Some of you can look right at that and get your answer. If you can't, use your change of base. You get 1/3. So you've probably already figured out number 12. All right, this concludes your video on basic form. If you will now go to your practice and go ahead and work on those problems, let me know if you have any questions. I hope you have a great day.